Hi, everybody. Mrs. Bixler here, and we are about to jump into RTD problems. You might have some experience with this stuff, and if you don't, totally fine. What I want you to do right now is I want you to pause the video and read this problem and try to figure it out. Do the best you can. All right, we're back. Hopefully you messed around, and if you found out that it takes Leon 2 hours to catch Michelle, you are correct. Woo woo! So we'll get into how you can do that. If you drew a picture or if you sort of did a little guess and check, totally great and awesome. We're going to talk about kind of a more efficient way to solve problems just like this. So when we talk about rate and time and distance, we know that the relationship between rate, time, and distance, rate times the amount of time you've been going that rate, equals the distance that you cover. And so rate times time equals distance. This distance is super important. And that distance is, the way we find that distance is going to be the same no matter what problem we're looking at. But what we do with that distance and the distances of the people involved will be different depending on what problem we're looking at. So there are 3 types of RTD problems. The first is a catch-up. The second is what we call a work done or an opposite direction problem. And the third one is a same direction problem. And now this third type you won't see as often. They're still pretty cool, but you'll definitely see more of number 1 and number 2. So let's go ahead and jump into number 1. Hint, you already saw number 1 on the earlier slide. So here is an example of a catch-up problem. And the reason why you know it's a catch-up problem is because if you read it, see how at the end, it literally says to catch Michelle. So this is a catch-up problem. And in a catch-up problem, you're going to set the distances equal. And if you don't know what I'm talking about right now, it's okay. Hold on. So we're going to set the distances equal. And what that means is we've got Michelle who's running a certain distance and she's going this way. And then Leon is like, I got to go catch her. And so he's going to run. And by the time he eventually catches her, their distances are the same. Their distances are going to be equal. So what we always do with these kinds of problems is we set up what's called an RTD chart. So this is what an RTD chart looks like. Rate times time equals distance. So I've got my columns there. And then I've got Michelle and I've got Leon. And then all I'm going to do here is I'm going to take the information from the problem and fill in my chart. So Michelle, I know her rate is 5 miles an hour, and I know Leon's rate is 10 miles an hour. Michelle, I don't know how long Michelle's been running. So usually in algebra or in pre-algebra, when we don't know how long something's happened and has been happening, we use a little variable. So I'm just going to use X. You can use T, you can use P if you want, you can use F, whatever, doesn't matter. Now, Leon though, Leon has not been running for the same amount of time that Michelle has. Leon has been running for 2 less hours. So it's going to be the amount of time that Michelle's been running minus 2 hours. And then all we need to do here is take this information and fill in our distances. So if rate times time equals distance, I know Michelle's distance is going to be 5 times X. And then Leon's is going to be 10 times, and you have to be careful here, X minus 2. I want to distribute here though, so I would get 10x minus 20. So we just did the biggest part of these RTD problems, and that's figuring out what the distance is. So I know Michelle's distance is 5x, and I know Leon's is 10x minus 20. And in a catch-up problem, remember, we know that they've traveled the same distance. So all you have to do here is just set the distances equal. So 5x equals 10x minus 20. So that would be our equation, and then all you have to do is solve it. So I'm going to subtract 10 from both sides, so I get negative 5x equals negative 20. So I know that x equals 4 hours. But look back at the chart. X stands for the amount of time that Michelle's been running. So Leon has been running for 2 hours fewer. So it takes him 2 hours to catch her. Cool? All right, so that's the first type of problem called a catch-up problem. I want you right now to pause the video and try this one on your own. Do it! All right, we are back. So hopefully you have an answer. And the first thing you did is you filled out your RTD chart. So here's what my chart looked like. I had Anna and then I had myself. Anna's rate was 4, my rate was 6, and then I was only running for 1 hour less than Anna. So hopefully yours looked like this. And remember, the distance is the most important thing here. So here's Anna's distance and here's mine. Because I'm catching Anna, I'm going to set those two distances equal to each other. So I'm going to pull this guy down. And your equation's 4t equals 6t minus 6. And so then you get t equals 3 hours. But remember, I have been traveling for 2. So it took me 2 hours to catch Anna. All right, hopefully you feel good about that one. Let's jump into the next type of problem. So this is what we call a work done or an opposite direction problem. And the way I know it's not a catch-up problem is it literally doesn't say catch up. So if you look here, there's no catching up, but there is work being done. So Fifi is frosting 15 cupcakes and Mimi is frosting 20 cupcakes in a minute. So that's their rates. And what we're interested in is we've got Fifi doing a certain amount of work. We've got Mimi doing a certain amount of work. And what we care about is when they together in total have made 280 cupcakes. So what you do for a work done problem is you add the distances. So we are going to add our distances together. This is the second type of problem, a work done problem, and we're going to add our distances together. I want you to pause the video, and all I want you to do is make the RTD chart. Go! Okay, we're back. So you made your RTD chart. I'm just going to show you what I wrote down here. And hopefully you got the same thing. So remember, all we care about is our distance. So 15x and 20x. Fifi's done a certain amount. Mimi's done a certain amount. And what I care about is when together they have made 280 cupcakes. So then I just solve my equation. So I get 35x equals 280. And then solve. I know that x winds up being 8 hours. Units are important here because it could be like cupcakes or little strawberries or hats or elephants. So you want to make sure that you use 8. All right, so that's the second type of problem. So in a work done problem, you're going to add your distances together. And here is our last one. So this one is called a same direction problem. And the way you know it's a same direction problem is because you're given 2 pieces of information, right? And they are traveling in the same direction. So these guys are also headed towards the Bahamas. Now, if you think about it, we've got the Norwegian cruise line going a certain distance. And then the Disney cruise line is also going a certain distance, but it passes it, so we think. So what we're interested in is this difference between those two. So this is what we call a same direction problem, and in a same direction problem, you subtract. Same, subtract. So we are going to subtract our distances. Same thing here, pause the video. All I want you to do is make your RTD chart. Go! Okay, we're back. I want to see your RTD chart, and hopefully it looks something like this. So what I care about now are my 2 distances. So I've got 24x and then 32x minus 32. If you're not sure how I got that, go ahead and look back earlier in the video. And then we're going to subtract them. So what you want to do when you subtract is you want to make sure that you are taking the faster one first. So we've got 32x minus 32. And then I'm going to subtract the Norwegian cruise line. And then I'm setting that equal to 350. Cool? Does that make sense? And then you just solve this equation, solve for x, and that's when you find out what your x is. Now you've got to be careful here because look back at the question, see how it says what time? So then you've got to think about, well, what time is that beyond 12 noon? So if we get like 4 hours or 8 hours or 7 hours, you've got to add that to 12 noon. Cool? Okay, you've got this. Go attack the worksheet. We will see you soon. Good luck.